So this is 8.6 part 1, double angle and half angle formulas. The first objective we're going to look at is the use of the double angle formulas. And these double angle formulas you're going to need to memorize because you will use them in calculus. So the first one says sine of the double angle equals 2 sine theta cosine theta. And then we're going to see 3 double angle formulas for cosine, and depending on what you're given is what you will use. So you can use any of the 3. But for instance, if you have both cosine and sine's values, you can use cosine of the double angle equals cosine squared theta minus sine squared theta. If you're just given sine's value, you can use the second one, which is cosine of the double angle equals 1 minus 2 sine squared theta. And finally, the last one is when you know cosine's value, you can use 2 cosine squared theta equals 1. And we also have tangent here. So tangent of the double angle equals 2 tangent theta over 1 minus tangent squared theta. So these are just rearranged, so you can do that. So here they are. And I'm going to move forward and just do this next example here. So this one says if sine theta equals 3/5 and theta is a value between pi over 2 and pi, find the exact value of. The first thing we got to notice is we're in quadrant number 2, and we're going to do part A. So sine of the double angle equals 2 sine theta cosine theta. That's the formula. So if you notice, we've got a small issue here is because we don't have cosine's value. So the first thing that you're going to need to do is go ahead and draw yourself a triangle. And I don't know what happened to my screen here, but let me fix that. And I'm going to put theta right here, and we know that sine is equal to 3, which is side opposite, over 5, which is the hypotenuse. So this is a 3, 4, 5 triangle, and if you don't believe me, do Pythagorean theorem. But when your legs are 3 and 4, then the hypotenuse is 5. All right. So since I'm in quadrant 2, remember that sine is positive, cosine is negative, and so is tangent. So I'm going to put a little note here so I don't forget. I'm going to go ahead and plug in these values. So 2 times sine theta, remember, was given as 3/5. And then I'm going to multiply that by cosine theta, which is going to be negative adjacent over hypotenuse, so it's negative 4/5. And the reason why cosine is negative is because I'm in quadrant number 2. So if I multiply this stuff together, I get 2 over 1 times negative 12 over 25. And I got negative 12 over 25 by multiplying 3 times 4 over 5 times 5. So now I have to just multiply this out, so I get negative 24 over 25, and that is my value for sine of the double angle. Now part B asks me to find cosine of the double angle. Since I know sine and I know cosine at this point, I can use any of the 3 double angle formulas. I'm going to go back up to the double angle formulas to show you that. If you're given a particular value right off the bat, I would use the formula that has that value in it. So I'm going to use 1 minus 2 sine squared theta here. And once again, the only reason I chose that is because I was given sine in the original equation. Now, like I said, you could use any of the 3 cosine and double angle formulas, but just to be safe, in case I made a mistake on my triangle, if I use what's given, then I'm not prone to making 2 mistakes in a row. So I'm going to go ahead and put that in there. 1 minus 2. Remember, sine is 3/5, and I'm going to square that value. So I have 1 minus 2 times 9 over 25, and I got 9 over 25 by taking 3 squared over 5 squared. And then I'm going to multiply that 9 by 2, so 1 minus 18 over 25. I'm going to find a common denominator of 25, and 1 becomes 25 over 25. So when I take 25 and I subtract 18 from that, I get 7 over 25. So that is the answer for part B. If you use the other formulas, you should get the same value. All right, so let's look at this next one. It says solve the equation. Sine theta cosine theta equals negative 1/2, where theta is a value between 0 and 2 pi. Okay, if I look at the left-hand side of this equation, this is nothing that I have. I don't have anything that matches up with this. But I do know that sine of the double angle equals 2 times sine theta cosine theta by definition. So the first thing I'm going to do is I'm going to multiply both sides by 2. And if I multiply both sides by 2, I get 2 sine theta cosine theta equals 2 times negative 1/2 on the right-hand side. So this left-hand side looks good, and I got to multiply 2 times negative 1/2, which I get negative 1. So now I have 2 times sine theta cosine theta. So my next step is to use substitution, and I'm going to substitute in for 2 sine theta cosine theta. So when I sub that in, I get sine of the double angle, or sine of 2 theta, equals negative 1. Now at this point I can't really solve it, so I'm going to use substitution. So I'm going to substitute by letting x equal 2 theta. So I get sine x equals negative 1, and now I can solve that. The only place where sine equals negative 1 is when x equals 270 degrees, or 3 pi over 2. That is the place where sine equals negative 1. Now I'm going to resubstitute in x equaling 2 theta, because remember my original equation started out with theta, so I have to end with theta. So I get 2 theta equals 3 pi over 2, and then I have to use the 2 pi k. So remember, whenever you have something around theta, that's not just theta, you have to use the 2 pi k with sine and cosine. So now I have to isolate theta by dividing everything by 2. So I get theta equals 3 pi over 2 divided by 2 plus 2 pi k divided by 2. Okay, so theta equals 3 pi over 4 plus pi k. And that's my formula. So this formula will allow me to find my values. Okay, so before I start plugging in for k, I'm going to look at my stipulation. So the stipulation is that theta has to be a value between 0 and 2 pi. So I want to make sure that 2 pi has a common denominator of what we used in our formula. And since I have 3 pi over 4, I'm going to write 2 pi as 8 pi over 4. So theta has to be a value between 0 and 8 pi over 4. I did this because I want to know where I need to stop. So now I'm going to plug in for k to find my values. So if k equals 0, I get theta equals 3 pi over 4 plus pi times 0. So that pi drops off and theta equals 3 pi over 4. That's an okay answer because that is smaller than 8 pi over 4. And now I'm going to let k equal 1. So theta equals 3 pi over 4 plus pi times 1. So if I put a common denominator in here, I get 4 pi over 4. That's what pi turns into when I have a common denominator. And if I add those together, I get 7 pi over 4. That is an okay answer as well because it is smaller than 8 pi over 4. Now, if I let k equal 2, I can tell you this is going to be too big because when I plug it in, I get 3 pi over 4 plus 2 pi. Now remember, 2 pi is equivalent to 8 pi over 4, so if I add 3 pi over 4 to that, I know it's too big. Okay, so my answers are, and let me write that curly bracket a little bit better there, is going to be 3 pi over 4, that's my first answer, and 7 pi over 4. Okay, so that's how I do objective number 1. I'm going to do another video covering the second objective in 8.6.